Thank you. Welcome. My name is Koen Hiemstra. I'm going to present to you today TotaLite, which is a simple and precise camera-based deformation monitoring system. So it basically is a sensor that can detect and alert people on movements, on settlements of buildings, infrastructure, so you know exactly that it is stable. And let's first start with the company. So we are a company called TotaLite, which is a tech company started in 2021. We're at the moment 12 people based in the Netherlands in Rotterdam, and we are a spin-off of Fugro, which is a big geospatial, geotechnical company, where the idea started and has decided to pull it out of the big company and have it run as a small startup focusing on selling this sensor and the platform that is linked to it. So we are building this TotaLite sensor and monitoring platform that I will show you today. So first, let's start with deformation monitoring and why this is important. So I want to highlight a few examples where there were issues with settlements and where deformation tooling, deformation monitoring tooling could have helped. An example that, at least in the Netherlands, is referred to a lot is the building of new metro tunnels in Amsterdam with a lot of damages on houses that were above the construction site, a lot of claims and problems that with good real-time monitoring could have been detected earlier and potentially been avoided. Another more catastrophic example is the bridge collapse in Italy, where from satellite data was shown that also this bridge showed some deformation that could potentially preempt its collapse. It's happening in UK on the rail track, which is due to climate change and droughts settling down. And same in Netherlands, one of the design mistakes in the high-speed train is costing a lot of money to repair and to slow down the trains. And what we see is that current tooling at the moment is not always scalable. A lot is happening with traditional survey equipment, happening either manually, making a manual measurement every week or every month, or automated, which is still quite expensive and difficult to apply. And on the other hand, we have geotechnical sensors, which, for example, are tilt meters or extensometers, crack meters that provide little information but are simpler to use. And we believe this can be done simpler, and we are started building a purely IoT camera-based system, so which is basically a camera with the benefits of a camera where you can detect multiple points with a single sensor. But it's a camera which is easier to build. The hardware is really simple, makes it cheaper, and all the intelligence is in the software. So that's became TotaLite, and the main benefits of TotaLite is to collect the precise displacement information with a lot easier and a lot more cost effective. You still have 24/7, every 5 minutes, accurate results. It's a lot easier to set it up because it's basically a camera that you would put somewhere and it starts making measurements, and it's a lot more cost effective. So how is it possible to detect those sub-millimeter movements with a camera? Also, we make use of target survey prisms as our monitoring points, and our camera will, with infrared light, illuminate the environment, and it will take pictures of the reflections of these targets. And because the reflections always look the same, we can really precise see pixel movement and convert that to real displacement in millimeters by telling the system the distance. So basically, at the start of a project, you will measure the distance from your TotaLite sensor to the prisms, and then we are able to convert any pixel changes into into displacement horizontally and vertically in millimeters. And by using this technique, we can measure day-night independent of the light, and we do this a very precise long-term performance. where we can achieve 1 millimeter at a distance of 40 meters, and we can detect targets up to a distance of 100 meters. So that's really, really precise. I'm going to show you a quick video how we've set it up. So this is how the camera looks like. You will mount it on a fixed position and observing the structure. It's opening and cleaning for every measurement, because with the previous version we had issues with dirt, rain, so we have now an automatic cleaning device. That the device runs through a very low power, because it's not other than the cleaning device, it's just a camera, so you can run it from a small solar panel. And then it uploads the data using a SIM card every 5 minutes to the cloud, where you can visualize the data and over a longer time analyze the movements of a rail track, of a bridge. You can set the measurement frequency and kind of control the device online from your laptop. So basically the camera, a few specs to highlight. So it runs low power, as I said, 2.7 watt-hour. We achieve 0.5 millimeter at a distance of 20 meters, and if you go to the max range, we'll achieve 2.5 millimeters. There is to connect it online, it has an integrated SIM card to upload the data over the mobile LTE network. We have Ethernet connection in case you need to install it inside the tunnel without mobile network. And we have Bluetooth, so you can configure it with an app on your phone. We have on board a MEMS sensor that will allow to correct for tilting of the sensor. So automatically we will level the sensor itself. So we are sure that we measure the actual displacement of the targets instead of the displacement of the camera. So with this, we enable to make it a really plug-and-play setup, which is also be possible to done by non-surveyors. That normally you would need a surveyor to control an automated total station system. This we designed to really be possible by anyone installing it in the field and configuring it. So the sensor is relatively small, making it also a bit more invisible into the public space. And others than a total station, you don't need maintenance, because you don't need calibration. It's just a one-off camera that we calibrate in the beginning, and then it runs for a lifetime of minimum 3 years. So we have the platform where we visualize both the raw data, which is angles, and we also provide displacement in horizontal and in vertical direction. You can export the data, you can have your API to connect it to your own platform, and we are also working on ways to automatically get alerts. That, for example, you have a bridge that you don't want to move more than a centimeter, that will automatically send you an email, SMS or WhatsApp when this is actually moving. So some in the field applications that I want to highlight. So the main areas where we have been applying this is on bridge monitoring, on construction sites, either monitoring the construction itself or monitoring houses and buildings around the construction site. Inside tunnels, monitoring the convergence of tunnels. For old buildings that are having cracks and all those kind of damages, and on rail tracks. So, for example, inside the tunnel, you install it inside the tunnel, monitoring a convergence profile like you see over here. And with one single sensor, you can cover multiple convergence profiles. And you will see over time how the tunnel is either shrinking or becoming bigger. We do small bridges, which are ideal for the camera. So normally here, a surveyor would go there every week to check the stability of this bridge. Now we have a continuous data set, and here we compare in red we see the TotaLite data, and in blue we see a manual surveyor making also measurements. So now you have online visibility in the stability of your bridge. One last example is on a rail track. Installing it on a structure next to the rail, monitoring multiple prisms on the rail sleeper. And here we simulated a movement with, again, in blue, a total station measurement. And in red, we have the TotaLite data that are both observing a movement of the rail of about 20 millimeters. This one I'm going to skip. So, as I said, so we are using TotaLite in applications where you need to replace manual measurements and you are looking for an affordable way to get automated and remote measurements. Or when you need really vertical settlement data instead of tilting information, or where robotic total stations are an overkill and you just need a simpler, more cost-effective device to monitor your deformations. So we have a stand over here, and we are running live demos, and I also can show you more of our validation campaign where we compare TotaLite to other techniques. And we're happy to welcome you there, and also to discuss potentially how you can have a demo unit and apply it on your project to learn how it works. That's it. So happy to welcome you at the stand downstairs, number 78. And if there's any questions, let me know.